many aspects of the migration can be put in a buckle as saying that's all migration and modernization, but they are pretty much different, and they may affect the decision that the customer chooses. So talking about rewriting software factory, what's that? It's really to have some kind of contract with people that will rewrite the legacy application to a new software architecture. But it's very difficult when you think about application with more than 30-year-old application, because for that, what kind of documentation you need? What kind of strategy we will build? Are you building a new application, or you're just rewriting the same application with a new language? All this is complicated when you think about rewriting software factory, because apart from the documentation, you have to break the line between old and new. And if breaking the line is a good strategy, which I personally don't think it is, unless your application today is completely outdated in functionalities or your business needs. So rewriting sometimes lead you to have an unfinished project because you are just designing a new thing based on an old thing that you don't have documentation at all in most of the cases. So rewriting is more suitable when you have applications that are not more generating revenue. For example, not having many users from the customer using that application, or the functionalities today that are completely unusable. In that matter, rewriting can make a lot of sense, but the market tends to say migration and modernization as a rewriting software factory. And in our experience, we've seen that it's pretty much difficult to get a 30-year plus old application and redo it through a software factory. The next one is a software package. Software package can work. Software package, I mean applications like Oracle applications, SAP, ERPs, and applications that usually attend some need from a business perspective. Software packages can work very well when you have a package that attends 100% of your needs. But in fact, what we see in the market is that you have to build a software factory besides the software package acquisition. You have lots of services beside that to change that package to be compliant with the business needs. And of course, it takes a long time to do that. And you ended up having a rewriting software factory besides the package you just bought. So can be a good option when it's something very unique, very exclusive. For example, software package for human resources, very specific with detailed functionalities already written. It can work, but in our experience, the legacy applications, when you substitute that with software package, you can lead to unfinished projects also, exactly like we have experience for rewriting software factory. The next one is hosting emulators. What are hosting emulators? There are software that pretend to do what the mainframe do in each aspect. For example, if you have COBOL, you have COBOL compilers to run those languages in these hosting emulators. If you run Kix, they have a Kix-like functionality in these emulators to run Kix, for example. So emulators makes the market feel that it's easy to implement a project like that. But then you run into performance problems. You run into business needs that need to be changed. With hosting emulators, it seems to be more easygoing in a perspective, but in really, at the end, you will be tied to a proprietary technology like you were before. So you pay for a software that will do exactly like your old mainframe environment does, and you have to pay the software fees, and you are not open to the new technologies available, like open source, for example. So hosting is really changing the problem from one place to another in our experience. And then we talk about transformation with process and automation. What we do really is to have a service process and tools to get the job done. And the strategy may seem very difficult because we are talking about changing software architecture. But in our experience with more than 100 projects delivered, we really developed a process, a service process, and a bunch of tools to do every aspect we need to transform the legacy architecture in a new architecture open for cloud and digital transformation needs. And that's what we'll be talking in the next slides. We can start in approach one, for example. If you have a legacy application and you are pretty much okay with the functionalities and to run that in the mainframe, but you are just running out of people, we can understand your actual application and do the maintenance for your application today. We are actually a very innovative mainframe software factory to maintain architectures like COBOL, CSP, Natural, Kix, DB2, AWS. So if you have an environment and you have the need, not just jump to modernize already the infrastructure, but needs to maintain your actual application, we can help you doing that as a first step, for example. You can start, of course, in the approach 2, which is understanding your actual architecture. In this slide, we call it architecture A. That can be traditional mainframe architectures like COBOL, CSP, Natural, using Kix, DB2, and many other kinds of database like Visa, AWS. And then we use our service process and software to get you to architecture B. That can be Java with application servers from the market like JBoss, Tomcat, and many others available, and get you to a relational database also from the market like Microsoft, Oracle, IBM, and many others. And then can be a second step, which we call migrate and transform. It can be an evolution from approach 1 to approach 2, or we can start directly in approach 2. In our approach 2 of changing the architecture A to architecture B, it means that we are just moving your application to a new software architecture, but all the characteristics of your legacy application remains the same, because we learned along the way that's the most effective way of doing this kind of project, because we maintain the investment you did in the past in the legacy technology. And then you have the approach 3, that this really goes after the approach 2, which is really modernize things, in terms of not only application functionality, but infrastructure. We can get from architecture B already out of the mainframe to architecture C, which is using a lot of new technologies like microservices, mobile technologies, the use of cloud containers to have elastic infrastructure. All that can be applied in a third step, which we call modernize, maintain, and develop. Okay, so the approach 2 is pretty much related to changing the architecture. If you have really the strategy of getting out of the mainframe, we can help you doing that in the approach 2. In the approach 3, once you are already out of the mainframe, once you have already cut costs, we can modernize that also with many tools we have to get you to a better infrastructure, a more scalable and elastic infrastructure, and also a new architecture of software, very much compliant with microservice, mobile technologies, and all this new digital transformation stuff you need. So we can start easy with us. I call that start easy and grow fast. We can really get you to a modern environment in a three-step phase. At first, I would like to clarify that if you have an application that you don't see your piece of code here or any kind of source we are saying in this slide, don't hesitate to contact us, because it doesn't mean we don't do that kind of project. It just means that we have already all the tools and process to attend these kind of sources. But as all the tools and all the technologies and process belong from us, we can really fast build your specific needs. So don't hesitate to contact us if you have any program language or any environment that you may find you don't find in this slide, because we really can build your demand in the lab. So we pretty much deal, when we're talking about mainframe migrations, with IBM and Unisys environment. Okay, so in the column of source, you see the kind of environment we work as a source in IBM and Unisys environment. So pretty much COBOL on both architectures. So COBOL from IBM, COBOL from Unisys. We migrate to Java, most of the time to Java, but also we can have migrations from natural to COBOL. It's something that we've been doing from some customers, because they don't want to get out of the mainframe, but they want to get out of the natural language. So we've done some projects where Java was not the objective, but going to pure COBOL with KXDB2 architecture. So on the programming language layer, talking about IBM, we can address COBOL, CSP, EasyTree, JCL, Oracle Forms and Report, which is a pretty much unusual environment to find, but we can also migrate Oracle Forms and Reports in open systems to Java, okay? Running on open systems to Java. So the targets are Java, COBOL, and all the GCL we transform in scripts. Regarding the operating system on the IBM environment, we can go from ZOS, VM, or VSE to Unix, Windows, virtual machines, and cloud. When you're talking about transaction servers, the environment can be Kix, complete if you're using natural, and all the patch processes. We transform that with the best of breed application servers available in the market, like Oracle WebLogic, JBoss, Tomcat, and WebSphere. Of course, we can have many other application servers in our migration target options. As long as it runs Java, we can use any brand to run our application servers. Regarding the database, you have DB2, AWS, Visa, and GGG as a source, and you can target any relational database available in the market, including the ones in the cloud, like Amazon Aurora. Is not listed here, but we already done a project using Amazon Aurora as a target for databases. When you talk about the interface, usually you have ISPF or 3270 screens. What's going to happen at first, and we're talking pretty much on our approach 2, is that your normal application you fit now in a browser with the same look and feel you had in your 3270 screen. It's the approach 2, okay? Because there are a lot of advantages in this aspect that I will be talking later for you guys. In the Unisys environment, we can do all the COBOL, Link, SATs, WFL transformation to Java and shell script. Operating systems can go the same as the IBM mainframe, go to Unix, Windows, VM, and cloud, okay? Environment application servers can go from COMS and batch to traditional application servers available in the market. And the database, the most common used database in Unisys is the DMS2. We can go to to relational database is also available in the market. The interface is pretty much the same what happens with the IBM mainframe. We have VT, 100 screens, SDF. We can transform those screens into a web browser with the same look and feel that you are used to have in your source application. So this is pretty much the candidates we have when you're talking about projects. But again, don't hesitate to contact us if you have something out of this list. 70% of our projects come after a software factory failure or inability to deliver what the customer wants regarding their legacy applications. I will give you some examples. We've been talking to a grocery store, very big grocery store in Latin America with more than 500 stores. They were a Unisys mainframe heavy user, and they have like 2 years to end up the mainframe support. And they called us to do a transformation project, and we did some proof of concept. They liked us, but they said, okay, but my system remains the same, and I would like to implement some new things, some new HTML, some new interface for our users. And we just said, okay, you can do that during the process, but once you are already out of this mainframe, because the objective is to attend this 2-year race that you have till the end of the contract. They closed with a software factory, the contract. And 1 year after, they called us again and said, guys, it's 1 year left to the contract, and we just move like 10 or 20% on the rewriting perspective. So this 2 year can become an 8 year, 10 year for us in this velocity. So can you do the same project 2 years ago in 1 year now? We said, yes, it's a challenge, but we can speed up process. We can speed up with more people, the testing and quality assurance to put in production. And what we did is that they bought our idea, their strategy of putting things together in the new architecture as it is, because that's the secret for that. We move your application as it is, maintaining all the original business rules, the name, the execution, the sequence. We preserve also the data names, the data structure. We preserve tables and fields. And most important, we preserve the user interface, because your end user, they go for the weekend on Friday using a 3270 screen. When they come on Monday, they have to recognize their application. And while it is in a browser, the application look and feel is the same. And then you can even discussing with the end user a better interface for them. And then is when it enters the modernization process. So when you're talking about money and speed, that's the best strategy. So we could attend the customer in this requirement of doing this migration in 1 year. It was a very big Unisys mainframe with more than 10 million code application. It was the application, the commercial application running on the stores for this grocery store. And we could do the project. Till now, they are using the same application, but it's completely renewed with all the modernization that they need, with all the mobile technology and the cloud technology that they are now able to use. So this is an example of how transformation and migration with the characteristics we use can be pretty much the way for legacy applications. I'll talk about each point, but it's more than characteristics of our transformation. It's really a path that we can guarantee that the projects are delivered successful. In this way, we got 100% of our projects delivered. We have 100% of our customers satisfied. Not always the projects were 100% profitable, but it's part of the learning journey, because really it's a very important matter when you talk about transformation, about migration. But let's see some points, and I will give some examples in the customer why we have these top characteristics. For example, migrated application with browser preserved interface. It's clear for us that the end user is one of the most important pieces when we're talking about legacy applications. You know, those users are working every day for years with some legacy application. And when you move that, if they get on the computer and look at the application and say, hey, I don't recognize my application, you are in a big trouble. You have to retrain all your end users. So one of the strategies we have is to preserve the old legacy interface in a browser. It doesn't mean that looks ugly. It means that the functionality is the same. And of course, once you have the user use it to work with a browser, we can evolve to a more modern interface. So the aspect of that is that no need of end user training. You can do your project, you can leave your new application available to the end user, and they just will use that inside a browser. Okay. The migrated business rules are migrated and preserved. So it means once we start doing the project, we start to document those business rules that are so important for the business, but they were most of the time not documented. Okay, so we migrate the business rules as it is, and we document that in the new language. Another aspect that's very important is when you detach your old architecture to these new one architectures, when we generate that in Java, all the Java classes that we generate are already structured to be used with cloud, web services, all the new demanding technologies that we have available. So from day 0 to day 1, when you are in production, the other day, you are available to apply all this new digital transformation technology available. Another point is, okay, a customer from government that we did a big migration was the court, a big court in Latin America. And they said, I have a lot of regulations that need to be changed every day. And I can't afford stopping doing those maintenance. And in our process, your development team can keep doing the maintenance in the old legacy technology while we are in migration. Because what happens is, once we've learned how you code, our tools can be up to 100% automatic in terms of changing and migrating in the language layer. We just set up a breaking point where we put the system in production, but your maintenance team can keep the maintenance while in migration. That's a very important point, mostly for government that has to attend some regulatory demands, that has to change the application every day. So that's a very good characteristic of our transformation. One point that is pretty much unique is that we rely on the knowledge of the people that is already legacy developer. That is very important. Some of our competitors, or some of the strategies available in the market, we see that they really create a wall between the legacy developers and the new developers. What we do is completely different. We create a bridge. We have methodology to train the legacy developers into Java, doing maintenance in their applications. They will recognize their legacy applications in this new environment. That's the kind of training we do for these legacy developers. And of course, they are very strategic for us during the migration process because they are the ones that have some knowledge about the legacy application. So we have a completely strategy of migrating people that has the knowledge of the application. And of course, we can attach new developers, new Java developers in the same application development and have a mixed team where the legacy developers will have a very important and strategic position in the game. Not, just being taken out of the game. They will be part of the transformation process. Another point very important is once your system, you have applications in production in the new environment, we have some tools as an option that the legacy developers can use for productivity. Some legacy languages like Natural and COBOL, they are very high in productivity. So we just built some tools for these legacy developers to use with these migrated applications, and it can help a lot to the developers to get the same productivity they have in the old technology. So these are the characteristics we have and that we rely on, that is a secure path for us to guarantee that the projects are successful. I think the unique point, and let's say the most important point, is that we are committed to take the legacy application from point A to point B with at least the same functionality and performance from the original environment. We are involved in all phases of the process till your application is running in productions. So your developers will be on board maintaining the application and your users will be satisfied. Here you can see the usual process we have. So from phase 0 to phase 4, we are involved in the project. Talking quickly about the phases, phase 0 is where we have application object assessment, analysis, and design. Is actually where we created the plan for the project, okay? And we have professional services, transformation experts, and tools to do that, okay? Once we have the project start, pretty much we have 4 phases. The phase 1 is code and data conversion, which means taking the objects from the customer to do all this conversion, okay? We have the DG Tech transformation experts involved with the actual application. Then on phase 2, we start the preliminary tests. That's much more on our side to understand how the customer codes and get exceptions, to find exceptions, to tune our tools to be as accurate as possible in the migration process. Once we did that in phase 1 and 2, we get some database and infrastructure ready for testing, okay? Once we have the process and tool pretty much 100% done for that specific customer, because each migration is unique, we go into phase 3 and 4, where we have more customer participation because we're starting some integrated tests and certification. We get end users involved, system analysts involved from the customer to qualify the migration we did. In parallel, also, we have the customer developers involved and start maintaining the system together with us in phase 3, okay? And of course, the last, during phase 3 and phase 4, we pretty much have the database and the infrastructure ready for production. And once we have that and qualified and test all the quality assurance of the application, we go for deployment in production. Once the deployment in production is on, we start our last phase we call nursing, because we are beside the customer, to have all the first impression on the system, on the application running on the new environment, participating on the calls, helping on the exceptions like any performance problem that may have, because we resolve performance problems on phase 3. Okay, we test all transactions from the application to make sure you get at least the same service level you had on the old legacy environment. So it's a 100% proven process that we have from phase 0 to phase 4 that we use in hundreds of projects, and we have documentation and tool to guarantee the success. It's pretty much straightforward, the phases, and it's been successful. I'm here with Luis Miranda that works for our lab, and we are just gonna see example of some COBOL code migration to Java, where, for instance, you take a library of COBOL programs to migrate, and Miranda will show us how the process works. Miranda, up to you.
Okay, the first step is to copy the COBOL source files into a folder, and using this software, we can just select one COBOL code or several COBOL codes. In this demonstration, I'm going to select everything here in this folder, and I will start the process. Okay, when I start the process, I can just check the programs being migrated, and it's telling each program migrated in the converted lines of each program. Okay.
So Miranda, we can see now that this is pretty fast. Yes. It's happening on the fly. So all the COBOL codes is being converted line by line, and okay, it's on the fly, correct?
Correct. Okay. In this example, we have more than 200 program files. In this case, we have 234 COBOL files and more than almost 300,000 COBOL lines. Okay.
That's amazing, Miranda. We can see that for almost 300K lines, we've done a process in less than 1 minute. So to convert millions of codes would be as fast as that. I assume it will not take much longer than that, right?
Okay, that's correct. Okay, we just we need to guarantee that we have all the rules set, and we just execute this program, this tool, and it will convert with this velocity.
Okay, great.
Okay, then the next step is to see the migrated Java files, the converted files. Yeah. And now we have here, we have all the COBOL files are converted to Java, and I will show that. Just wait a minute. Okay, here we have the Java file, and in every migrated file, we inserted the original COBOL file. Okay.
Okay, so it's just a minute. So you're telling that for every program converted, we can see the original source code. So for comparison reasons, is pretty much easy for the programmer to compare codes, right?
Right. Okay. And during the test process, we can just check anything you want in the original COBOL code. For example, if you think something is working, it's not correctly, we can just check how the original code should work and check if it's working correctly. Okay?
Great.
Great. Let me show here. I will just put the two files. Okay, look here. I'll just show the original COBOL file and the converted COBOL file. For example, this paragraph will be migrated to a Java method. Every COBOL command will have a method or a class that is equivalent. For example, we have accept, we have the ifs, we have the moves. We implemented also, it was necessary to implement the go-to command. We can implement the perform command, another paragraph, here's another paragraph, and so on. So for every COBOL command, we have an equivalent in Java, so it makes pretty easy to compare the two codes. Is it clear?
Yes, perfect. The good point here, Miranda, that we can say is that you created kind of a bridge between COBOL and Java, so the developers can very easy identify the kind of code that they used to deal with, and now the future is much clearer for them in terms of understanding their code. That's awesome.
Okay, not only this. With this, we can guarantee that the behavior of a command will be exactly the same in Java. For example, the move command in COBOL, you can move numbers to text to number. We have set of behaviors in this move command. And so it's very easy to implement all this behavior in Java. If you do not do this, the test process will be very hard.
Yes, clear? I understand. Okay. Understand. If you get pretty much different things, it's very tough to test the programs after.
Yes, and the more important thing in the migration process is that we need to understand the original code, okay? And we need to guarantee that we'll have the same behavior in the new technology. After that, you can change anything you want. But in the first moment, you need to guarantee that you have one line here, we have this behavior in the other side, okay?
Nice, Miranda. Can you go to see some screenshots, some screen examples of the migrated code?
Okay, I'll show now. Just wait a moment. Okay, we have here the migrated code of a screen, just like it is in the mainframe, for example.
Yeah, it's a screen that looks like the mainframe 32.7, but it is in a browser, right? It's just, let's say it's the first process, the first migration.
The first step of the migration, the presentation layer, we'll just see the screen exactly as they were created in the mainframe, in the COBOL files to be executed in the mainframe. So here, we can just see if I want to update a player, for example, I can just see, just wait a minute. If I want to update this player, here we have Roger Federer as the first player, and I can just update anything I want, okay?
Okay.
If I want, I can go back to the menus, and I want to see a list of all the players we have in this application. So we can see all the players listed in this screen, okay?
Okay.
But this kind of presentation is not acceptable in the new world, okay? So we can just change this, and we can just modernize these screens to have this presentation here. For example, if I want to see the players now, I can just create, update, put photos, have a list, and we can just do anything I want in this kind of screen, modernized. So it's much better to see your application using this new layout. Okay. For
Very
example,
good.
if I want to see the grid with the players, now I can put photos, I can change colors, I can put buttons, everything that have the same content using the same program, but you can see in a different way, much better than the original source code. Okay?
Okay. That's great, Miranda. It means that when we think about migration process, a first step would be to go this system to put the application live as it is, because you have a lot of users as application users that need to be retrained if you go straight to a modernization screen layer, where you have to retrain maybe some end users on how to use this new interface. So we can do it is in a evolution process where we migrate the application as it is. It goes to a browser looking like the mainframe, and then we can modernize that. Is that right?
Yes, yes. The first step is first to guarantee that the users can still work with the applications. Okay, nothing has changed. Okay, and after that, in a second step, you can just improve some layouts that you want. Okay, with this approach, we guarantee that the functionality is 100% okay. And after that, we'll start the second step, that is to modernize all the screens.
Our assessment most of the time came in two phases, okay? We call the first phase assessment, where it's just a first clue, the first clue for us about the aspects of the legacy application to be migrated. And this is very easy. It's a spreadsheet that the customer fills, where they will talk pretty much about the application, the line of codes, the number of line of codes, the integration with other systems. So we get a first impression of size, the related programs between, and the dependencies with other application, external interfaces, all it's filled in that spreadsheet, and it gives a first impression for us. After that, we can have a deeper assessment, where usually we sign an NDA to exchange some objects, to get some libraries and objects from the customer, and we feel a tool that it's a tool that do a complete analysis of code, a tool from our side that does that deeply. So I can find blank lines, I can really see the line of codes involved for the migration process. Because in our experience, about 20 to 30% of line of codes are trash, repeated things, programs, version of programs that are not used anymore. It doesn't call nothing. So it really clarify for us on the second phase of the assessment, really the size of the project. So we can start easily with the first phase of the assessment, which is just filling a spreadsheet. And the second one is a deeper analysis, where we get objects and do the analysis.